Welcome to Spreadsheet Geek. In this video, we'll take a look at running a Monte Carlo simulation without the benefit of a simulation add-in. This method of running a simulation is a little more limited on the input side and the output side, but it'll get the job done if you don't want to buy an add-in. This video was made using Microsoft Excel 2019. You might want to review my previous video on data tables. This method will make use of data tables to run a simulation. You may also be interested in my previous video that shows how to conduct a Monte Carlo simulation using an add-in. Let's review our problem. I'm going to use the same exact problem that I used in my previous Monte Carlo simulation demo. We run a fruit stand in the summer. This is our expected summer fruit demand in kilograms. So we believe there's a 15% probability that we will have customer demand in the range of 1,500 to 2,000 kilograms, and so on down the line. We will buy our fruit at $2 a kilogram. We will always sell it at $6 a kilogram. And if it's about to spoil, we can unload it to a local farm at 20 cents on the kilogram. Whatever range of demand we decide we're going to go with for that season, our order will always be at the top end. So if we think it's within this 2,500 to 3,000 kilogram range, we will order 3,000 kilograms of fruit. Those are the givens of our problem. Let's review briefly what we did before with the benefit of a full Monte Carlo simulation add-in. What I did was I generated a random number between 0 and 1 using this formula right here, and every time you hit the F9 key, it recomputes a random number between 0 and 1. From that, I used this random number to generate one of these numbers up here. And I did that by doing a VLOOKUP from this number down into this table in this column here, doing an approximate match, and it returns one of these values over here. So I'm using a random number to generate a produce order. In similar fashion, I have another random number between 0 and 1 here in this cell that generates an amount of sales or produce sold. In this case, it's just a random number between 1,500 and 4,500, which are the extreme high and low of what we expect our demand to be. And there's one constraint on this number in that it can never exceed the produce ordered. So I just used an if statement to calculate that value. Then I calculate my sales revenue based on how much we sold times the unit sales price. I calculated our cost by the amount we ordered times our cost, and any disposal revenue. If we ordered more than we sold, we can get rid of it at 20 cents, and that results in our final profit. Now, this works fine if you have a simulator add-in. You can have these two variables. In fact, you can have many more than just two variables, but with this poor man's data table method, we have limited results. In fact, our results are basically limited to one number, and for us, that'll be profit. So for each profit number we generate, we need to associate the order level with that profit. We will actually run 6 different batches of trials at each of these order quantity levels. And while we're doing that, we'll let this random number generated produce sold number float freely, giving us a profit. You're not going to get as much information back using this method. This is the information we got back with our Monte Carlo simulation using an add-in. And you can see all of the detail of each one of your trials, cost of goods, disposal revenue, if any, and profit, So this is really good for analyzing, and these are just the ones at 2,000. If you scroll down further, you can see the orders at 2,500 kilograms and 3,000 and so forth. Another thing I was able to do with the Monte Carlo add-in was control the distribution of trials through my random number generated formula. So roughly 15% of my trials were at 2,000 kilograms and 20% at 2,500 and so on down the line. And that was really right in accordance with my table here. That's going to have to be done manually using this poor man's method. So let's redo our problem here a little bit and get started. The first thing I'm going to do is fix my order level at the first batch of trials, which will be 2,000 kilograms. Then I'm going to go ahead and copy over and just paste over this VLOOKUP table because I don't need that anymore. And I don't need this random number generated anymore. So I took some time to create a little table to capture all of my trials. The first two columns are for the 2,000 kilogram trial, which we're going to run first. And I'm going to run a number of trials that are proportionate to these probabilities over here. So to kind of keep these in the same proportion, I'm going to run 1,500 trials in this 2,000 kilogram order range and 2,000 here and 3,500 here, 1,500 and so forth. So I just want to number my trials here. Let's fill in these cells with a good thing to use is the fill series function here. We'll fill this column with steps of 1 and stop at 1,500. So if you go control down arrow, you can see there's 1,500 of them. I'm going to go ahead and set up the other ones while I'm at it. Let's run the 2,000 kilogram trial. The first thing we want to do is make sure this is set to 2,000, which it is. In this cell right here, I'm going to set this equal to my profit, which is there right now. And then I want to go highlight by hitting Shift and down arrow the entire data table. I'm going to manually scroll back to the top and go to Data, What If, Data Table. And we're going to leave the row input cell blank. And since we're in a columnar format, I just need to pick a cell that Excel can use to compute the different trials, and that will be in each of these, this cell right here. Then we fill those numbers in. So we've got a lot of 8,000 profits there, but there's some other different ones that are below 800 down here. Now, before you move on to the 2,500 kilogram trial, you need to fix these values. So I'm going to highlight them all, copy, and paste as values. That'll preserve those forever. Now I can go ahead and change this to 2,500 and run my next trial. Same way, set this cell equal to your profit, highlight the whole table. This time you'll notice it goes down to 2,000 trials because that was our agreed upon number of trials in that batch. And I'm going to go back to Data, What If, Data Table, ignore the row input, designate a cell for calculations, and hit OK. Once again, I will copy those and paste as values. I'm going to repeat that exercise for the remaining 4 trials. Okay, I finished all of my trial batches at the different levels of order. Now somebody might say, well, since 2,500 kilograms to 3,000 kilograms is the most probable level of customer demand, why don't you just run that trial and focus on that particular bin? Well, there's two things in play with this problem. One is we want to maximize our profit, but two is we want to minimize our risk, and our risk is disposing produce at 1/10 of what we paid for it. So if we want to be really safe and not dispose of anything, we should order down here, because customer demand is likely to be much higher than that, and we'll sell everything we order. On the other hand, the maximum profit is down here at 4,500 kilograms ordered and 4,500 kilograms sold. So we don't exactly know how this falls out in the middle ranges here, and we want to weigh that risk of loss against the opportunity cost of lost profit. That's what a Monte Carlo simulation is good at doing. So let's start taking a look at these results. I've added a little summary table here, and I'm going to compute the average of each trial here and see where we stand. And I'm also going to calculate the median for each as well. So that'll equal... I'm going to repeat this exercise for the other trial batches. So I completed my little summary table showing the average and median profit at each different level of order. And one thing I noticed right away is that these results in the average column differ quite a bit from my results with the Monte Carlo simulation add-in I used. I'm going to pull those averages over just by copying this table. So when you look at those, you'll see that the 2,000 kilogram average up here is 7,700 pounds. It's a little bit more here, a little bit more here. These numbers all tend to be higher, but they are pretty darn similar to the median. Those are pretty close until you get up into this range, and then they drift away. So I would chalk these differences up to a couple of things. Number one, when I ran this Monte Carlo simulation with the add-in, I had control over this variable, and I gave it a uniform distribution, and I gave this one a normal distribution. So when you do this poor man's simulation, I'm not sure if what kind of distribution it's using here. I would assume uniform, but maybe somebody could tell me in the comments section. The second difference is that this was for 30,000 trials, and this one was something less than that, probably only 10,000. Actually, it was exactly 10,000 trials in this one. So it's only 1/3 the data points that we got from our Monte Carlo simulation using an add-in. So I think those two factors account for some of the difference. And the other factor is just that when you run two different Monte Carlo simulations, you're unlikely to ever come up with the same answer. There's a finite number of trials you can run. So what's my final answer? Well, based upon the highest average profit here and the highest median profit here, I would probably order 3,000 kilograms unless I'm feeling like taking on a little more risk, then order 3,500 kilograms. And that's very close to the same result we would get from the Monte Carlo simulation add-in. Those are the two best answers there as well. So that's my take on the poor man's Monte Carlo simulation using data tables. If you want to learn more about Monte Carlo simulation demos using a Monte Carlo simulation add-in, please check out my other video where I solve this exact same problem. I also have a video on data tables if you want to learn more about data tables. If you found the content of this video interesting and useful, please consider hitting my subscribe button. Thank you for visiting Spreadsheet Geek.